Okay, here's my test setup for our little PID tuning experiment. I have a vessel here, or a bowl, basically with half of a liter of water in it. I'm going to heat the water. That's going to be my process. I have an immersion heater here, just a low power 300 watt, pretty safe unit here. I've got an RTD probe that's measuring the temperature of the water. My XL4 is my controller here. I'll be executing the PID on the XL4. We are going to be using a on-off control or a digital output from the PID loop that is going to run through a solid-state relay that is controlling the heater. Okay, so that is our physical setup. Let's head to Seascape and take a look at how we have it set up here. Okay, here's my PID. I'm using the auto tune option as well as the ISA option. All right, have everything configured using variable base advanced ladder. Let's go take a look at our auto tune settings. All right, I've assigned a start bit and a done bit, a couple of Boolean variables for the auto tune function. I'm going to go ahead and tune all three elements, P, I, and D. From a controller response standpoint, I'm going medium. From a noise filtering standpoint, I'm going with the minimum. And that's because I'm not concerned about electrical noise causing my process variable, which in my case is my temperature, to bounce around a lot. I don't think that's going to happen in my case, so I don't need a bunch of noise rejection or noise filtering. I'm going to tune at the full set point, not 2/3 of a set point. I might check that if I was concerned that a big overshoot at my full set point could cause a problem for my machine while I'm tuning. So but I'm not concerned about that. Okay, now let's go take a look at the tuning page. So here's what I have set up on the tuning page, or at least a reflection of the tuning page. Don't have any of the coefficients set yet for P, I, and D. The auto tuning is going to give me a starting point for that. My sample period is 100 milliseconds. No bias has been configured. I don't have any deadband, upper or lower configured. You'd set a deadband if you didn't want your CV to be hunting around a lot near the set point. In my case, I have a solid state relay controlling a heater. I have no concerns about any kind of mechanical wear out or mechanical life shortening of my devices that are controlling my process. So therefore, I'm not concerned about a few extra cycles on the solid state relay, so I'm not going to set deadband in this case. Upper clamp 32,000, lower clamp minus 32,000. Those have to be set that way if you're using a digital output to control a PID loop. Okay, I'm leaving error term, slew time, output polarity, and derivative all default, and I have enabled PWM, which is basically indicating I'm using a digital output to control my process. And I'm setting the cycle time at 0 because, again, I'm not concerned about cycles that happen frequently on my solid state relay. No issues there. Now, even though the output is a on or an off, I'm still, the OCS PID loop is still doing an integer-based CV calculation. Now, if the value of the CV happens to be below 0, then my output will be off. My digital output will be off. If the CV calculation results in a 0 or higher, then my output will be on. So that's what will be happening. Okay. During the tune, we can monitor what's happening on these bar graphs. In my case, my process variable and set point are scaled to the point where they're not going to get above about 8,000. So I'm going to narrow in my range there to make it more meaningful. All right, and I think I'm ready to start my tune. So let me switch over to my lab setup here. All right, I'm in manual mode. You can certainly tune from manual mode. That's not a problem. My heater's enabled. I'm going to go ahead and set my set point for tuning at 60 Celsius. Currently, my water before heating is at 17 or 18 degrees Celsius. Let's go to my tuning screen, and I should be able just to kick off the tune here. There we go. You'll notice my SSR is on. So what we're going to be executing here, or what we are executing here, is a Ziegler-Nichols tuning experiment being automatically run by the OCS. So what's happening here is the OCS will run the process to the set point and actually a few degrees above the set point, and then it will drop it back down below the set point, actually a few degrees below the set point, and it will do that 3 times. Okay, and during that time, it's calculating some values, it's monitoring some values, it's doing some timing calculations, and at the end of those 3 cycles, it will come up with a suggested or a set of coefficients for P, I, and D. All right, and then we can take those and test them and see how they do. All right, so that's where we're headed. Now, as you can see, the temperature has started to move now. It takes a little bit of time, of course, for the heating to actually start to the point where we can measure the temperature, but now the temperature is moving. So I'm going to go ahead and let that run, and while it does, I think I'm going to go ahead and try and put our tuning screen on display here. So let me see if I can turn that on. Okay, now let's switch from our tuning window to a chart. Now during auto tuning, you have to get above the set point by a little bit before it actually turns off. So you can see in this case, after 0.3 degrees C, based on the scaling, we turned off the SSR. And so even though the temperature continues to creep up because of inertia, we are now headed down on the first cycle. So we're going to need to go below the set point by a similar amount that we went above it before this cycle will be complete. Okay, you probably noticed that the solid state relay turned back on again once we got below the set point by a few tenths of a degree. So we're now actually on the second cycle of the auto tune experiment. Okay, this is our last cycle and we're on our way down. As soon as we get below the set point by 2 or 3 tenths, the auto tune should be complete. And it is. You can see the done bit come on. Now as soon as I turn off the start auto tune button, you'll see the done bit goes off as well. Okay, all right, so that's auto tuning. Okay, now that we're done auto tuning, I need to close this window and reopen it again, and then I can see my suggested tuning parameters. Okay, or actually these are the ones that are now in place. All right, so the next step is always to test these because there's no guarantee they're going to work at all, frankly, although they usually do work pretty well. There's also no guarantee that you can't improve them through a little bit of manual tweaking. So the first thing we need to do, though, is we need to actually test these and see how well they work. Now we're still in manual mode, so I'm just going to hop right into automatic mode and we'll see what happens. Okay, so I'm going to leave my tuning screen. Okay, and I'm going to switch into automatic mode. Now these parameters that were just calculated are being put to the test, and we'll see how those go. Now one thing that I'm keeping my eye on here is that we're actually getting further away from the set point. So that's obviously a concern, and if it continues, then my thought would be that we may have a scenario where the integral term is creating problems. That's not unusual in some applications. So as you can see, we are definitely headed the wrong direction. Let's head back to Seascape and take a look at things here. I am looking here at the CV calculation, and again, as long as it's negative, the output is off, okay? So every once in a while, it'll pop on for a short period of time. But we're continuing to get further and further away from our set point, continuing to drop. Okay, so what I'm going to do now is I'm going to clear out, back in Seascape, I'm going to clear out this integral term, all right, by typing a 0 and hitting Update Controller. And immediately, my output turned on. Okay, my CV calculation went to maximum immediately. So that kind of gives me a pretty good clue that it was my integral term that was causing problems with my output, or at least preventing it from staying on long enough to get closer to the set point. Okay, let's head back to the bench and take a look, and hopefully we can see after we overcome the inertia of the water, we hopefully will be able to see the temperature climbing up instead of down. Yep, there we go. So you can see the solid state relay is on longer, and you can see that we are now headed the right direction in terms of temperature. All right, let's watch this and see how we do as we approach the set point. Okay, we're approaching the set point from below, and it'll be interesting to see what kind of overshoot we get. So it looks like 6 or 7 tenths of a degree was our overshoot on this first time through here. Now let's see what it looks like on the bottom side of the set point. Okay, so about 0.75 probably. I saw one little bit of 0.8 below the set point there. So it looks like we're within about, at this stage at least, we're within about 1.5 degrees Celsius. Pretty well centered around the set point. We'll watch it for a while and see how it does. Okay, the next thing I'm going to try and do is I'm going to see if increasing our derivative term is going to make a difference. And to really see if that makes a difference or not, I'm just going to go ahead and double it. All right, so I'm going to take it from its current value all the way up to, let's say 90. All right, basically doubling it. And I will hit Update Controller, and we'll see what kind of impact that has. It doesn't appear to be helping. If anything, it probably appears to be taking it the other direction. So I'm going to let it go up through this cycle, and then I'm going to try reducing it by half. So it was at 45 originally. I doubled it to 90. Next, I'll try dropping that down to, let's say, 20 to see if that offers an improvement or not. But I'll wait a couple minutes before I do that. Okay, now normally I would let this run a little while longer, really on all these trials, frankly. But for the purposes of demonstration, I think I've come to the conclusion that these changes to the derivative have not really made a difference in the positive direction. So I'm going to go back to the original coefficient value after the auto tune, and I would imagine we'll settle back in at about, plus or minus 0.7 or so. Okay, now one thing I want to have a quick discussion of, and that is the proportional term. I haven't played around with the proportional term at all. If I go through and do a calculation on kind of the different proportional terms I might be interested in using, basically the calculation I came up with was, say, 64 was about the largest proportional term I wanted to use, and that would be because of how close to the set point, for instance, when we're heating water that's just been poured in, how close to the set point do I want to be before I turn the heater from 100% off to some lower level? In other words, from a CV calculation of 100%, how close to the set point do I want to be before that CV calculation drops below 100%? So, and by the calculation I've made, if I have a proportional value of 64, then I'm going to keep that CV calculation at 100% up until 5 degrees before I get there. So basically what I'm saying with this long-winded description is the suggested coefficient of 56.5 is pretty close to 64, so I don't think bumping it up to 64 is going to make much of a difference. It might save a few seconds in heating the water from the beginning, but it might have a negative impact on how tight we are or our overshoot. So I think I'm going to leave things alone. So to summarize, for at least this reasonable tune, where I'm plus or minus 0.7, I took the tuning parameters that were suggested or found during the auto tuning, and then after trying them out and seeing that we were unable to use those parameters exactly, I basically zeroed out the integral term because it was pretty obvious that we were in a runaway situation, both directions. So by zeroing out the integral term, we got things to plus or minus 0.7, and the other things I've tried so far haven't really improved anything. Okay, so I think as I let this run, it'll probably settle back in again to where we were when we started. And hopefully this was a good demonstration for you.